Okay, girls, so parabolas. So parabolas. The first feature that is important about parabolas is that it is a curve. You will be able to see parabolas everywhere in the real world. An example is like the Flinders station. Here we have a parabola. I don't know. I'm thinking that this might be Southern Cross, but I'm not 100% sure. And I'm embarrassed that I say that in this video because I might be wrong. But you can see here that in this roof, in the ceiling, we can see here that there are also parabolas. But something that is very important that I want you to notice here, girls, is that it's a curve. So when you're graphing your parabolas, please no straight lines. It is completely curved. So practice those handwritings. The girls are artists will find this very, very easy. Now, the other important feature, it is symmetrical. So if you see here, I have this parabola and you can see that it's completely curved. And here I have the line of symmetry. In this case, is the y-axis. So we can see that this half, if I fold this graph over the line of symmetry, I will get exactly the same on the other side. So it is completely symmetrical. I just remember that I wanted to say something about this. If we go back, sorry, girls. Where is it? Yeah. For example, in this one here, you can see here, like here we have the line of symmetry, and you can see here that it goes 0, 0, and then it goes 1, 1, 4, 4, 9, 9, 16, 16. Okay, so it's symmetrical. And the same happens on the other one, in this one, look, that we graph here. -1, -1, -4, -4, -9, -9, -16, -16 is completely symmetrical, okay, in this case. Okay, let's continue where we were up to here. Okay, so we were saying that it has an axis of symmetry. Wonderful. It has either a minimum, so in this case that I have this parabola, it has a minimum, okay? Sometimes parabolas can be graphed as well. This is also a parabola, and we are going to learn to identify all of these ones well in this unit, so don't worry about it. But it also, when it's upside down, we can see that it has a maximum. So it has either a minimum or a maximum. These points, minimum and maximum, are called the turning points. Why are the turning points? Because it's where the parabola changes direction. If you remember when we were looking linear graphs, we will say that a graph in this direction will have a positive gradient. Agree? Because it was going up the stairs. Bling, 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 bling. So we can see here that it has a positive gradient, positive gradient, positive gradient, positive gradient. It gets to the turning point, and what happens, girls? Negative gradient, negative gradient, negative gradient. That's why it's called turning point. If we look at the previous one, we were talking about minimums, the same happens. Look at this. Negative gradient, negative gradient, negative gradient, negative gradient, negative gradient, negative gradient. Turning point, positive gradient, positive gradient, positive gradient, positive gradient. The turning point is where the parabola changes direction. It was going downwards and now it's going upwards. And in this case, it was going upwards and now it's going downwards, okay? So these minimum and maximums are called the turning points. Very important, this word. Okay, the basic shape of the parabola is y equals x squared. And that's what we have here. And that's what you graph, where we have when x is 0, it goes through 0. When x is equal to -1 and 1, y will be equals to 1. Look at here. When x is equal to -1, y is 1, but also when x is equal to 1, y is 1. What will happen with n when x is equal to -2? So y is going to be equal to 4. Agree? Because -2 to the power of 2 is positive 4. But the same happens when I have, what is the value of 2 squared? Also 4. And we cannot see it here, but if I will go to -3, what will be the value, girls? 9. I'm hoping that you're saying 9 around here. And what about 3? 9. And with 4, 16. And with -5, 25. And so on. Agree? Okay. Let's look at the main features of the parabola. So when they're asking you to draw a parabola, they usually will ask you to draw these features. The first one is the axis of symmetry. So these parabola that I have here have suffered some transformations. We are going to cover these ones later on, but that's not the point here. The point here is I want to identify those axes of those main features. So I have my parabola, and we want to identify what is the axis of symmetry. So if we fold it in half through this point, look, it's exactly where the turning point goes. In this case, because I have a happy smile, it is a minimum, agree? But exactly through that point, if I do my line there, and what is this line? Is that special line, x equals 1, y is x equals 1, because regardless of the value of y, x will always be 1. Boom, 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 boom. That's my axis of symmetry. Beautiful. Turning point, also called the vertex. It's also important that you familiarize yourself with the vertex. In this case, and this is important, in this case, it is a minimum. If the parabola was upside down, then it will be a maximum. But in this case, it is a minimum. And what is this point? It's 1, -1, okay? The other important aspect, feature is the x-intercepts. So if we look up here, this parabola is going through the origin, 0, 0, and 0, 2. Now, I just want you to stop here 1 second and write this in your notes because this is important. Not all parabolas have x-intercepts. Depending on the transformation that the parabola is having, what happens if my parabola was drawn here? It will never touch the x-intercept, the x-axis. So it won't have x-intercepts. So that's very important. Not all parabolas have x-intercepts. Please write that down in your notes. Very, very important. Sometimes the x-intercept, I just want to go back to this one. Look up here. Is just touching the origin. So in this case, I only have one x-intercept because the x-intercept is 0, 0. In this case, I only have one. But when I have a parabola like this one, you will see that you have two x-intercepts, okay? So sometimes it has one, sometimes it doesn't have, and sometimes has two, okay? Can it has more than two? No, it can't. So those are the options. It doesn't have any, it has one, or it has two, okay? Now, y-intercept. In this case, the y-intercept was also the x-intercept because it's going through the origin. So I have drawn another parabola here with other modifications to show you another y-intercept. So this is a different parabola to the one that I had before. And in this one, we can see here that the y-intercept will be 0 and 3. What is important to notice here? The y-intercept, as you know, is when x is 0. Agree? Because it's when it's going to cut that y-axis. Okay, girls. Fantastic. Just going back to this one, and the x-intercepts is when y is 0. So we can see here. Oh, this is wrong, girls. Please modify. Thank you that I noticed this. It's wrong. Please change it in your notes. I'm going to write. How do I want pen? Can I have a pen here? Yeah, pointer, pen. This is wrong. How do we write this point, girls? It's 2, 0. Please change it in your notes. Miss Ochoa made a mistake here. Wrong, wrong, wrong. Okay, this point is 2, 0. So now, x-intercepts, when are the x-intercepts? When y is 0. Y has to be 0. Wonderful, girls. With this, we finish our introduction to quadratic graphs. Now you can go and continue with the next step outlined in your digital book.